further out, and everything would be fine. That's the size of Mars. You could put Jupiter a few thousand AU, that's 1,000 times the distance of Neptune, and again, you're safe. There might even be things out there that we might find. He goes on to say, it's not impossible that the Sun has a brown dwarf companion, but to be hidden from us, it would have to be much, much further out than the Kuiper belt, maybe like 100 times further. And at that distance, its effects on the Earth are pretty much zero. Now, a brown dwarf star in our near solar system, there have been models of this, I think I talked about it last time, of this thing coming in our solar system, what it would do to our planets and stuff like that. It's amazing. We wouldn't be saying stuff like, oh, you know, the sun is getting hotter. We would be saying, hey, our calendars no longer work and everything is going crazy. And that's before it even gets that close to us. So I just want to really, really reiterate that this thing would be extremely noticeable, even if you take all the theory. Anybody that has a Planet X theory has to do this thing first. They have to explain why nobody can see it, why you can't hear, smell, taste, touch, why it's invisible to every known possible thing. And so they come up with all kinds of theories, some of which we'll talk about in a minute. But the main thing they can't and don't have an answer for is why can't we feel it? Because the gravity is the thing that would do it, even if you gave them that it was somehow invisible. And of course, if this thing is as big as it's supposed to be, it would be occulting stars behind it, even if it was black and had no light, which is altogether impossible anyway. But especially if it's a brown or red dwarf, yeah, they're dim at certain distances, but when they're close, they're like a star. So yeah, if this thing is close, not only would it be bright, but I'll even give them, okay, let's just say it's not bright for some ridiculous reason, it would still be blocking out a whole bunch of stars if it was close. And so some people say it's coming from the south, you see. All the planets are going around the ecliptic, okay, which the ecliptic is a flat, if you just, the middle of the sun is the ecliptic, and all our planets are basically not exactly right on the ecliptic. They're actually on various, but they're basically more or less on the same plane, orbiting the sun, except for Pluto, which has a slightly irregular orbit. And so they say, no, it's not on the ecliptic. It's going, in a sense, in an up-down way, a perpendicular to the ecliptic. And so it's going to come at us from the South Pole, and we'll talk about the South Pole telescope. Even if it was doing that, it's not going to escape the gravity effects of the sun. I mean, that's like an elementary point of Newton's laws of gravity, that a sphere will act, gravitationally act in all its directions, not just on the ecliptic. The reason why things, orbit in the ecliptic ultimately is because they orbit to each other's center of their mass. It's such a common thing that even if you look at galaxies, you'll notice that they are all in disks. Even after, of course, all this time, they are orbiting in a disk-like shape. You don't see a big ball of a galaxy. They're in a disk. That's because that's how things do that. When you say, oh, well, this thing is coming in an up-down way, and that's why you can't see it, number one, it would still gravitationally mess with everything, and you'd still be able to see it. This is the same way that a lot of comets come in from that area. There's a cloud of comets around us. They call it the Oort cloud. And then there's another band of comets called the Kuiper belt. The Kuiper belt's like about a light year past the sun or something like that. And it's basically a big asteroid belt on the outer rim of our solar system. It's orbiting the ecliptic. But then the Oort cloud is just basically like that, a big cloud around our solar system kind of thing. They will get kicked in, and when they get kicked in, they come at us in all kinds of weird orbits and stuff like that. Or weird trajectories, I guess you could say. So it's not like, we don't know anything about those just because they're coming in from odd trajectories or whatnot. So not only is that wrong, the idea that it's coming from the south is just a way for them to say, oh, well, here's one reason you can't see it. But I think, as we talked about last time, that makes no sense either, because spherical geometry is such that if you're standing on, for example, the North Pole, you're able to see half of the night sky. It's not exactly perfect, but if you're standing other places on the Earth, if you have a flat terrain, you can, throughout the course of the entire night, you'll be able to see half of the night sky, more or less, give or take. So from the equator, over the course of a year, you're going to be able to see the entire south sky. But anywhere below the equator, of course, you're going to be able to see more and more and more. And there are lots of examples of this. I mean, it's well known. The Gemini telescopes that's what they boast about, that they see the entire night sky collectively. There's two telescopes. One is like in Arizona or something, and one's in Chile. And because they're on both the north and south hemispheres, they can image the entire sky together collectively. And so you don't hide anything by putting it on the South Pole. The South Pole, of course, the South Pole telescope is the big thing. The government's trying to hide it from you. But if the government's trying to hide it from you, they have a really funny way of showing it, because they built this massive, expensive telescope that is completely worthless for imaging dwarf stars or planets or stars or anything else. They built this great, extremely expensive telescope that doesn't even operate on infrared. It operates on, if it imaged a planet, it doesn't do planets. It doesn't do dwarf stars. We have dwarf star telescopes that are way unbelievably good, like WISE and IRAS, which we're talking about in a minute. But the South Pole conspiracy is ridiculous. That telescope operates on millimeter and sub-millimeter and microwave bands. These are huge bands you could measure on a ruler, and they are non-visible. The goal of the South Pole telescope is to image galaxies in the cosmic background radiation. It's to image things that are so distant. It's specifically tuned to do things that, by them being able to do those things, they make it impossible for them to be good at searching for Planet X. So it requires an ignorance of what is actually there in order to say it's all about Planet X at the South Pole telescope. It's definitely not about Planet X at the South Pole telescope. So dwarf stars in general. Let me back up and tell you again the story of Planet X. This is important. Masters leaves this completely out. No, he tells the story, but he forgets the most important part of the story. Just real briefly, the story of Planet X is this, that in the 1800s, after they started discovering these outer planets like Uranus and Neptune, they started to notice that, according to Kepler's laws of planetary motion, if those laws were accurate, then there was something going not quite right with their orbits. Mathematically, it wasn't able to be explained according to Kepler's laws of planetary motion. So what they called that is perturbations. They were being perturbed, that is, gravitationally perturbed. And the hypothesis was true with Neptune. This is actually how they found Neptune, where they said, okay, Uranus is not doing right. It is therefore mathematically probable that it's being perturbed by something, and that something should be right about here. And they said, would you go please look in this area of the sky, because I think something will be right there. And lo and behold, they found Neptune. So it really bolstered the case of this idea of, if you've got a perturbation, you can do the math, and the math on perturbations, as you can guess, is ridiculously difficult. But people do it. And so after that, though, they found Neptune, and it basically explained a lot of the things on Uranus. There were still some issues, but we later know that those issues were, let's say, operator error. The issue is this. So there were still some problems after they found Neptune, and they hypothesized that it's okay, it worked last time, let's do it again. It must be a massive planet out there, based on their calculations. Whatever was still perturbing them would have to be a massive planet. It would have to be like a Jupiter-sized planet, and that would, according to their calculations, sort of solve the problem, if there was such a planet. So the race was on to go find the planet. And then they found Pluto, and they were happy at first because they thought it validated the theory, but as time went on, they realized that Pluto was not a very big planet, and therefore could not account for the gravitational anomalies on Neptune and Uranus. So then Marshall Masters stops telling you the story. And no more story after that. For Marshall Masters, he'll essentially conclude like, and now nobody's yet found Planet X, but the search is still on. But in the real world, the search stopped in 1992. Because in 1992, Voyager 2 went past Neptune on its way out to the outer solar system. It saw Neptune and saw something interesting about it, that it was actually just a little bit smaller than they had previously thought. So it was actually, I think it was 0.05, I think it said 0.5 last time, a little bit smaller than that.